Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter quadratic form, lecture number 1, in which I will convert the quadratic form as metric products x transpose multiply A multiply X, this product of three matrices. Before going to the main content, I would like to motivate you with the help of this expression. In this expression, we see that in each term, the sum of the powers of the variables be 2. Here x to the power 2, here y to the power 2, here z to the power 2, here x to the power 1, y to the power 1, sum of the powers is 2. Here also y to the power 1, z to the power 1, sum of the powers be 2. Here also power of z be 1 and power of x be 1, means 1 plus 1, 2. So in each term, sum of the powers of the variables be 2. And so this expression is known as quadratic form. Now here we see that here we have 4xy. We may write this as 2xy plus 2yx. 2yx means 2xy. Here 5yz. We may write this as 5 by 2yz plus 5 by 2 zy. Similarly, here we see 6zx. 6zx. We may write this 3xz plus 3zx. And we write this x square plus 2y square plus 3z square plus 4xy plus 5yz plus 6zx equal to. Now we write this as, here we write xyz. Firstly x multiply x. Here 1 into x multiply x, then x multiply y, here 2 multiply x multiply y, then x multiply z, xz plus 3 xz. Then now we start with y, yx, here plus 2yx, then yy, here 2 multiply yy plus, then yz, here yz 5 by 2 yz plus, now we start with zx, 3 multiply z multiply x, then zy plus 5 z multiply y, then zz, here 3 multiply z multiply z, implies that we take this in matrix form, single element, x square plus 2y square plus 3z square plus 4xy plus 5yz plus 6zx equal to, here 1 multiply x plus 2 multiply x multiply y plus 3 multiply x multiply z plus 2 multiply y multiply x plus 2 multiply y plus 5 by 2 multiply y multiply z plus 3 multiply z multiply x plus 5 by 2 multiply z multiply y plus 3 multiply z multiply z. Let this is number 1. Now we write x equal to 1, y equal to 2 and z equal to 3. Then here we see x equal to 1, 1, 1. Here 1, 2. Here 1, 3. So we make a matrix A. 1, 1 position. Coefficient 1. 1, 2 position. Coefficient 2. 1, 3 position. Coefficient 3. Now y2. 2, 1 in 2, 1 position. Coefficient 2. Here 2, 2 position. Coefficient 2. 2, 3 position. Coefficient 5 by 2. Here z equal to 3. 3, 1 position. Coefficient 3. 3, 2 position. Coefficient 5 by 2. 3, 3 position. Z 3. 3, 3 position 3. X equal to column matrix x, y, z. This is 3 by 3 matrix. This is column matrix 3 by 1. Implies that transpose of x equal to x, y, z row matrix. 1 by 3 matrix. Let this is number 2. This is number 3. This is number 4. Now x multiply A. X, y, z multiply 1, 2, 3, 2, 2, 5 by 2, 3, 5 by 2, 3. This will be equal to, now multiply first row, first column, x plus 2y plus 3z. Now first row, second column, 2x plus 2y plus 5 by 2z. Now first row, third column, 3x plus 5 by 2y plus 3z. This is a row matrix. Now transpose of x multiply A multiply x. Transpose of x multiply A is this. We write this firstly. X plus 2y plus 3z. Here 2x plus 2y plus 5 by 2z. Here 3x plus 5 by 2y plus 3z. Multiply x, x, y, z. Column matrix implies that transpose of x, Ax equal to, we multiply this firstly. This is first row, multiply first column. Firstly we multiply this and x. 1 multiply x multiply x plus 2 multiply x multiply y plus 3 multiply x multiply z plus we multiply this and y. 2 multiply y multiply x plus 2 multiply y multiply y plus 5 by 2 multiply y multiply z plus we multiply this and this. 3 multiply z multiply x plus 5 by 2 multiply z multiply y plus 3 z multiply z. From 1 and 6 we get that right hand side equal. Here right hand side this and right hand side this. Therefore left hand side equal. Transpose of x a x equal to, this is x square plus 2y square plus 3 z square plus 4xy plus 5yz plus 6zx implies that we may write the expression x square plus 2y square plus 3z square plus 4xy plus 5yz plus 6zx as matrix products. Of the form transpose of x a x. This is the quadratic form, and we write this quadratic form as the product of three matrices. Transpose of x multiply a multiply x. This is the practical approach to form a quadratic form as product of three matrices. We give a proof for this. Now we define quadratic forms. An expression of the form, here sigma I equal to 1 to n, sigma j equal to 1 to n, aij xi xj, where aij's are elements of a field F, is called a quadratic form in n variables x1 x2 dot 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 xn over a field F. If this field F equal to R set of real numbers, then this expression is called a real quadratic form. Now we prove a theorem. Theorem is every quadratic form over a field F in n variables x1, x2, dot 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 xn can be expressed in the form of product of three matrices, transpose of x multiply matrix B multiply matrix X, where X is a column matrix. This is row matrix and transpose is column matrix, is a column vector, and B is a symmetric matrix of order n over the field F. Now we prove this. Let sigma I equal to 1 to n, sigma j equal to 1 to n, aij xi multiply xj be a quadratic form over the field F in the n variables x1, x2 dot 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 xn. Let this is number 1. In 1, it is assumed that xi multiply xj equal to xj multiply xi. Then total coefficient of xi multiply xj in 1 is written as aij plus aji. Let us assign half of this coefficient to xi multiply xj and half to xj multiply xi. For example, if the coefficient of xi multiply xj is 6, then half 3 will be with xi xj and half 3 will be with xj xi. Now define another set of scalars bij such that bii equal to aii, means diagonal element same, and bij equal to bji equal to half of aij plus aji when I not equal to j. This is number 2, this is number 3. Therefore, we get that sigma of I 1 to n, sigma of j 1 to n, aij xi xj equal to sigma I 1 to n, sigma j 1 to n, bij xi xj. This is number 4. Let capital B is n by n matrix. This is a symmetric matrix because here we see that bij equal to bji, and the symmetric matrix of order n over the field F. Since x equal to, this is a column matrix, and if we take transpose of this will be a row matrix. Since x is a column matrix, so here we have n rows and 1 column, and this is x transpose is a row matrix. So this is size 1 by n and B is of size n by n. Now x transpose multiply B, x transpose is size 1 by n and this is n by n. So if we multiply x transpose multiply B, we will get a matrix of size 1 by n. So x transpose multiply B is a matrix of size 1 by n. Now we multiply with this matrix x. Since x transpose multiply B is a matrix of size 1 by n and x is size n by 1. So if we multiply these two, we get a matrix of size 1 by 1. It is easily seen that 1 by 1 means this matrix contains single element. That single element of this matrix is sigma I equal to 1 to n, sigma j equal to 1 to n, bij xi multiply xj. Therefore, x transpose multiply b multiply x equal to sigma I equal to 1 to n, sigma j equal to 1 to n, bij xi xj. This is, and already we have seen that this equal to sigma I equal to 1 to n, sigma j equal to 1 to n, aij xi xj. Therefore this quadratic form, I equal to 1 to n, sigma j equal to 1 to n, aij xi xj equal to x transpose b x, and proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.